Hello folks, welcome to part 5 in our 5-part series on statistical reasoning. Today we're going to look at some serious statistical analysis frameworks that has been put out there for us to consider. I think let's start straight away. The framework we're looking at has been developed by Sharma et al. In 2011. It is a 4-stage framework and it diagnoses students' thinking on statistical literacy pretty much in the same way that the Van Hille levels did for us in geometric reasoning and Mark Driscoll's work. So let's not waste time, let's start. Stage 0 to 1 is the informal or idiosyncratic stage. Now you've heard this word in the 4th part of the series being used quite significantly or often in descriptions. So students at stage 0 and 1 are exhibiting characteristics of pre-structural or at most unistructural thinking. Well, let's see what that means. There's only an informal engagement with context, very informal engagement, often reflecting intuitive, non-statistical ideas and beliefs at the informal or idiosyncratic level. Due to reading or writing difficulty, students are unable to explain their thinking and often guess answers. With respect to statistical terminology, students provide random and inappropriate idiosyncratic, in other words, explanations. When making inferences, students focus on imaginative storytelling or inappropriate aspects. Students use subjective reasoning to describe measures of center or spread in the data at the level, the informal idiosyncratic level. The questions that are asked by students are not based on the data or is focusing on irrelevant contextual issues at this level. Students are successful at some basic table and graph reading at stage 0 to 1, as these require understanding of single elements and basic one-step straightforward reading. So that's not a compound thing that the learner is looking at. It's a single element and one-step straightforward reading. Stage 2, the consistent non-critical stage. At this stage, students are exhibiting characteristics of unistructural or multi-structural thinking. Well, what do we mean by that? Let's see. Here, students can focus on a single relevant aspect or attempt to attend to one or more relevant aspects of the data, but they have difficulty integrating these aspects. So this is what sets level 0 and 1 apart from level 2, is the fact that here they can focus on single relevant aspects or one or more relevant aspects of the data, but they cannot integrate the aspects, connect those aspects. Appropriate but non-critical engagement with the context is what happens at this level. So they can engage with the context, but in a non-critical way. Mostly affirmative, yes, that's right, that's what the context says. Okay, there's accurate use of statistical skills associated with simple statistics and graph characteristics. Okay, so you can see the growth between stage 0 to 1, the idiosyncratic stage, to the consistent non-critical stage. At the non-critical stage, students don't necessarily think critically about the object that they're using or the object that they are looking at. Single or partially correct comparisons are made within the data table or in the graph. So things are only partially correct at stage 2. General or single statements are made about the data collection methods and validity of findings with no reference to the context. The findings or the methods that are used, if they get to the correct answer, is correct because the mathematics that was done is correct. But there's no critical engagement from results back to context. No reference to the context at all. Questions asked are valid, but only based on one aspect of the data at stage 2. Stage 3, the early critical stage. Students at this stage are beginning to exhibit characteristics of relational thinking. Now folks, that is big. At level 3, the early critical level, is where relational thinking is happening. Students at this stage can attend to more than one relevant aspect of the data and are beginning to integrate those aspects. Okay, let's see. What happens? There's a critical engagement in familiar contexts. So they can critically think about things in contexts that they are familiar with. There is selective engagement with unfamiliar context, with some form of justification at the early critical. So you can immediately expect at the next level, the child can work across familiar and unfamiliar contexts. Remember, this is the early critical stage. There is appropriate use of terminology, qualitative interpretation of chance and appreciation of variation. The appreciation of variation, very important. So that at the early critical level, this is where the child starts thinking, but why is the data varying? What does this variation in the data mean? What does it mean if the data is very spread? So students demonstrate awareness of relevant features of displays, measures of center and spread. However, these are primarily based on the data or context, but not both. Okay, the measures of center and spread is based on the data or the context, but not on both. Questions asked of the data are based on more than one aspect of data tasks, but not always connected. Students are likely to relate several elements together about data collection methods and graphing. Here they can manage two variables at the same time. So at the early critical stage of functioning statistically, this is where we start working with bivariate data and looking at regression models and discussing them in class to build on the statistical thinking and literacy of the child. Stage 4, the last of the 4-stage framework, is the advanced critical. Students at this stage integrate statistical and contextual knowledge that extends abstract thinking. They have the ability to relate several aspects of tasks together to use as a basis for prediction, for generalizing, for reflecting, or creating of new understanding. Okay, let's see how this happens. Well, there's a critical questioning engagement with the context. At stage 4, the advanced critical, the child pays a lot of attention to the context of the data. There's an understanding of the purpose of the data displays, the measures of center and inference and spread, and inferences are made at the advanced critical level. There is a critical evaluation of data collection methods, choice of measures, and validity of findings that shows appreciation of variation and the need for uncertainty, in making predictions. So here the child starts getting comfortable with the uncertainty that statistical reasoning affords in terms of its reasoning and in terms of its answers of questions. And a child can also appreciate why variation, what it means to the question at hand, and interpret what that variation actually tells us about the data. Here, sophisticated statistical and mathematical skills are associated with success at this stage, especially in media contexts. There's an ability to interpret subtle aspects of language in statistics. One word changes in a sentence in statistical class, it means completely something else. And that happens often when we work in grade 12 with counting principles, or when we work with probability. Okay? Questions are based on relevant features of the data and the context using multiple perspectives. The 4 stages, although examined separately in the framework, folks, are closely linked. For example, the ability to analyze and interpret data builds or comes from the ability to read data displays. That's why it's so important in the statistical reasoning class that children are literate or have some form of literacy in terms of reading graphs, whether those graphs be purely mathematical or whether those graphs are representative, of a statistical summary, voting patterns, temperature fluctuations. All of that is necessary. Understanding how to read graphs is necessary for statistical thinking and statistical literacy, and also necessary in developing the statistical reasoning capability of a child. Okay, folks, that brings us to the end of our 5-part series on statistical reasoning. I hope that this made sense. I hope that it opened up your mind and your head about thinking of what it is and what it means to be a good teacher of statistics and statistical reasoning. I am sure that if you bear in mind what these articles and these frameworks have given you to think about, then you will find that there's an improvement in the way you teach statistics and statistical reasoning to learners in school. If you've learned something from this video, folks, please like it, share it with somebody that might benefit from it, and subscribe to my channel. Thank you for watching.